Go to intro practice question number 2, and it says, what is the frequency heard by a person driving at 15 meters per second towards a factory whistle that is blowing at a frequency of 800 hertz? Assume the speed of sound is 340 meters per second. Okay, so important things to note over here. Is let us start once again with our Doppler effect, equation, right? So I'm going to list it over there. The frequency of the listener is equal to, open bracket, V plus or minus VL over V plus or minus VS multiplied by the frequency of the source. Now, in this particular case, you see, the person is driving towards a factory whistle that is blowing at a frequency of 800 hertz, right? So I've got a factory whistle over there. It's blowing at a frequency of 800 hertz. And of course, the factory whistle is stationary, right? And so what that means is that this thing over here, that's going to be my frequency of the source. That's going to be the frequency of the source. So I'm going to make it F little s. And of course, this person is driving at 15 meters per second. That is the velocity of the listener, right? The velocity, or rather the speed of the listener. That's the frequency of the source, and we have 340 meters per second. That's our constant, the sound, the speed of the wave, which is V. Okay. Now, again, if a person is driving towards the whistle, a person is driving towards this whistle, what we will find is that it's going to appear as if the whistle, the sound coming from the whistle, it sounds like it's getting louder as you approach it, right? And what that essentially means is that the wavelengths are compressing, and therefore you're going to get a higher frequency. Now, again, I want you to remember the English part of this. When we say higher, we mean higher than. We mean higher than the actual true frequency of the source, because the Doppler effect is more an appearance. It is what you are going to detect it as. Okay, so when you answer this question, the very first thing is you're going to write down the frequency of the listener is equal to, open up your bracket, and you're going to multiply it by frequency of the source. The whistle is stationary, right? So in other words, when the whistle is stationary, the Vs value will be 0 because the source is not moving, okay? Which means at the bottom, I'm only going to have V, this part falls away, and on top, I'm going to have VL. Now, in this case, I need the frequency of the listener to be greater than the frequency of the source, and if the frequency of the listener is going to be greater than the frequency of the source, then I need my fraction to be bigger than 1. Okay, because I want a number in here larger than 1. So if this needs to be larger than 1, the numerator must be a plus, so that I have the top bigger than the bottom. And what's that going to give me? That's going to give me, let's substitute in the actual values now. It's going to be 340, right, plus 15 meters per second divided by 340, okay, multiplied by 800 hertz. And that whole thing has to be a little bit higher than 800. Okay, so that gives us a solution here of 835 hertz, comma 29. So it's 835,29 hertz. Okay, so if we test our intuition, we can clearly see when I am approaching somebody and I am approaching a sound source while that source is emitting a frequency of 800 hertz. As I approach it, it will appear as if though it is more than 800 hertz to me. Okay.